biology students, sorry that I ran out of time on that other video. So this is part 2 of the dihybrid and blood types and X-linked traits with SpongeBob SquarePants. We're taking a look at 3, 4, 5, 6, and 7. Take a moment to look at those and see if that looks old to you and if you know what's going on. So if we look at number 6, why are there more colorblind males than females? Males are always XY. They can either get the normal gene or they can get the abnormal gene, and they get the Y chromosome from their dad, so Y makes them the guy, but the mom can either pass on the abnormal or the normal gene. If a son has a trait, it's usually because the mother gave it to him. If the son is a son, it's because the father gave him the Y chromosome. So why are there more colorblind males than females? Females can be normal, homozygous. They can be normal with the abnormal. That makes them a carrier. That still makes them normal. Or they could get 2 recessive alleles in this case. This would have to come from the mother, who is either a carrier or has the trait herself. And this has to come from a father who is indeed affected by that X-linked, sex-linked trait. So what are the chances that a female has 2 parents that have the recessive genes? Probably not as likely as having at least a mother who is normal and another mother who might be normal but still has that recessive allele. So sorry for all that chicken scratch. I'll get rid of that here in a moment. Thanks. So males either have a 50-50 chance or females have only a 1 in 3 chance of getting the recessive trait. For number 7, a crabby blind whale. How would you rate his genotype if he is a male? He's XY. And if he's blind, he got the abnormal gene. He married Pearl, who has normal vision. So she at least is normal, but we don't know what her other allele is. One of their sons from the blind father and the normal vision mom, they have 2 sons. One of them is also colorblind. So what are the genotypes of the parent? The crabby blind male must be this guy. But how could Pearl have a son that is colorblind? What do you know about her X? She must also have that X subscript N. Superscript. Sorry, not a subscript. Superscript. So she is heterozygous for the trait. Here's a Punnett square down below to show. If he, the father, is X blind, Y, he makes these 2 sons sons. He makes these daughters have that little n, the abnormal gene, and mom is normal vision. So their first daughter has the good gene. The son would have the good gene. He can see. Yay! This son down here, though, is a son because the dad made him the son, but mom gave him the abnormal gene. He is blind. But this little girl also would be blind because dad gave her the bad gene and mom gave her the bad gene too. So number 7, what's the genotype of the parents? Capital, lowercase, capital. That's the bad gene right there. Mom has the good gene because she's normal vision. We didn't know this other one, but now we do because she had a son who got her bad allele. For question number 8, in Sandy Squirrel's family, her parents don't have hemophilia, but one of Sandy Squirrel's brothers has it. So he is XnY. He's a guy, but he got the bad gene. Who was the carrier for hemophilia? Sandy doesn't have it. Her mom and her dad don't have it. So where did the bad gene that he got come from? Dad gave him the Y. Mom must have given him the X. So X, capital N, X sub N is from the mother. Mom made Sandy Squirrel's brother. Mom of Sandy Squirrel is the one who had the bad gene that she gave to her son. So we're now done with questions 1 through 8, and I'm going to move the page up. I just want to make sure we're all in the same spot. Thank you. So take a moment to look at number 9 and come back to me here in a moment. Ready to go on? SpongeBob. He has the disorder. So he's X p Y. Sponge Susie genotype. She is XX because she's a female. She's said to be a carrier. So she has the good gene and the bad gene. Make a Punnett square to show the possible genotypes of their children. So she is the carrier with the big and the small. He does have it, so it's the little. So we get X big P, X little p, X little p, X little p, X big B, Y, that's a guy, and X little p, Y. What are the percentage of their sons that will have this disorder? 1 of the sons. 1 out of 2. What percentage of their sons will be normal? 1 out of 2. So it's a 50-50 chance for the sons to get it. What percentage of their daughters will have the disorder? That's again 1 out of 2. This one will be normal, like the mom. What percentage of the daughters will have the disorder? 1 out of 2. What percentage of the daughters will be normal but carriers? 1 out of 2. What percentage of their daughters will be normal non-carriers? None of them, because she either has the good gene but carries the bad gene, or she actually gets the trait herself. Take a moment to look at question number 10. See you back in a moment. So we know in this scenario that Squidward is wide-eyed, so he would have the recessive trait. He's X little r Y. Squidona, we know, has red eyes from her parents. Both of her parents are red-eyed, so we can assume or think that she got both capital letters. Let's do their offspring in the Punnett square next. So we know that Squidward is X little ry, like right here, and we know that she should be big R, like right here. So if they have offspring, like on this Punnett square over here, then there's going to be red, 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 all red-eyed children. Make a Punnett square to show their possible genotypes of their children. They're either X big R, X little r as females, or X big R, Y, like the mother, but dad made them the boy. So what percentage of their sons will have white eyes? 0. What percentage of their sons will have red eyes? 100%, all of them. What percentage of their daughters will have red eyes? All of them, 100%. What percentage of their daughters will have white eyes, but be colors for the red-eyed trait? I think that they kind of messed that up here. White eyes is going to be the recessive trait. None of the daughters will be white eyes. How many are carriers for the white eye trait? That would be both of these daughters, here and here. They are red, but they have the gene for the white eyes. I think that maybe that was a bit of a goof on this paper. Not mine. I didn't make it. What percentage of their daughters will be white-eyed non-carriers? None. I have one more question for you, though. Do we know for sure what Squidona's genotype must be? Take a moment, think about it. So lastly, do we know for sure what Squidona's genotype is? We know that her mom had red eyes, and we know that her dad also had red eyes. She's not a boy, so who cares about this Y down here? We know that dad could pass on that dominant gene, and mom could too. But is it possible that mom could have been a carrier? Could this be Squidona here with a lowercase r? It could be possible. Maybe she is a heterozygous person instead of being homozygous, since both of her parents had the red gene. We don't know that that's what they gave her for sure, because maybe dad gave her the good gene, we know for sure, but maybe mom gave her this one. We don't necessarily know. Thanks for being here. Thanks for watching. I hope this helped you with your key.